Hey guys, so I'm going to go over your Algebra 2 review on basically most of it's about polynomials, and so most of the things are factoring. The last few problems do ask about adding, subtracting, and multiplying polynomials. Alright, so let's dive into number one. Number one, as you can tell, is a three-term polynomial. So that's called a trinomial. Alright, so when we have trinomials, we factor them through the process we do in my class. It's called tic-tac-toe. Alright, so to start this problem off, we draw a tic-tac-toe box. Now, after we've drawn the tic-tac-toe box, what goes in the top left is the quadratic term. So in this case, that's 2n squared. Okay. Then in the middle here, we put the constant term. So that's your -9. I did not know that was going to be the color. That's kind of interesting. Okay. We multiply these two, 18n squared. Okay. And then let's see here. Let's find a different color. Green. Out here to the side, we put our linear term, which is 3n. So we need to find two numbers that multiply to this but add to this. And those two numbers are going to be 6n and -3n. Because when you multiply 6n times -3n, you get -18n squared, but when you add them together, you get 3n. Now what we do is we ask, what is 2n squared and 6n, what do they have in common? And that's what I'm going to put right here. Well, they, in common, have a 2n. Okay? And then we look and we say, what do 2n squared and -3n have in common? They just have an n. Now we say 2n times what is 6n? That's 3. n times what is -3n? That's -3. So we go across, we go across. We end up with the factored form of 2n minus 3 times n plus 3. Okay? Let's move on to our next problem. Alright, so number two, once again, it's factoring. It's three terms. So guys, we're going to dive into this situation the exact same way. We're going to draw a tic-tac-toe box. We're going to put the quadratic term in the top left, put the constant term in the top middle. Then to get the top right, I will multiply the two. So 3n squared times 4, well, that's 12n squared. Then out here to the side, I put my linear term, which is a -8n. So I need two numbers that multiply 12n squared but add -8n. That is 6n, -6n, and -2n. Then I ask myself, what does 3n squared and -6n have in common? A 3n. What does 3n squared and -2n have in common? Just an n. 3n times what is -6n? It's -2. n times what is -2n? -2. So we go across, we go across. We get 3n minus 2 times n minus 2. And there we go. Okay? Number three. Now, I haven't been saying this because I've hoped you just remember from in class, but the first thing we're always supposed to do in every single factoring problem is the GCF. And up till now, in both other problems, the GCF was just 1. In this problem, we have a GCF of 3 because that is the number they all share. So we can pull out a 3. Oh, that is not a good color to choose. Let's back that up and just switch using that. So that's 3. So then that changes the 9 to being a 3. So I say 3k squared plus 22k plus 7. Now I still have a quadratic trinomial. Okay, this is still a quadratic trinomial. So that means I am still going to tic-tac-toe. Usually after you pull out the GCF, you still look inside your parentheses and see if there's not some more factoring you can do. Okay? So then I'm going to say 3k squared, 7. That gives me 21k squared. I put the linear term out here, which I'm out of space. That's 22k. So what are two numbers that multiply up to 21k squared but add up to 22k? That's right. 21k and then 1k. Then I say 3k squared and 21k. What number do they have in common? That's right, a 3k. 3k squared and 1k. What do they have in common? Just a k. 3k, I don't know what that was. 7. K times what is 1k? That's 1. Go across, go across. So we get 3 times 3k plus 1 times k plus 7. Boom. Oh, that's a k plus 7. That's k plus 7. My handwriting's only getting worse. That was k plus 7. Okay, let's move on to our next problem. Number 4, which says factor. And in this case, we're factoring the sum of cubes. So what could you cube to get x cubed? That's right, x. What could you cube to get 27? That's right, 3. Now we just have to remember the formula that we talked about in class. A cubed plus b cubed, if I have. So then I can change that to being a plus b times a squared minus ab plus b squared. Okay? So in this case then, for this problem, my a would be x and my b would be 3. So then I can come in here and I can plug into this by saying x plus 3 times x squared minus 3x plus 9. I got the 9 because it says b squared, and b in this case is 3. All right, very good. Let's try to do number 5. Now, if you've just been following along so far, I highly encourage you to try to pause at number 5 and do it on your own. So hopefully you're unpausing this video, and hopefully you're like, oh, that's another sum of cubes situation. And 8x cubed, well, that's just 2x cubed, plus 27, well, that's just 3 cubed. So then it can go right into that formula where a is 2x and b is 3. Therefore, the a plus b part would be 2x plus 3, a squared. So if I took 2x and squared it, I would get 4x squared minus a times b. So that's 2x times 3, so that's 6x, plus b squared, so 3 squared, that's 9. And there we go. Okay? Number 6 says factor, and we have 4 terms. But remember, factoring we always do first is the greatest common factor. So what number do all 4 of these share? Well, they all have a 5 in common. They all have a 5 in common. So when I pull out 5, I get 21n cubed plus, let's see, 5 goes into 17 3 times. Then I'd have 25, so 35 n squared minus 5 goes into 7 one time. 5 goes into 7 one time with the remainder of 2, so 15. I don't know why I didn't know that. I don't know why that took so long. 15n minus 225. Wow, I was really slow on that. I apologize. Okay, but now we look inside our parentheses, and we still see 4 terms. Okay, so 4 terms means I can still factor by grouping. So I just carry down my GCF. Now look at these first 2. What do these first 2 have in common? What do just these 2 have in common? Well, they just have a 7n in common. So when I pull out, 7n squared. So when I pull out that 7n squared, that gives me 3n plus 5. Now look at these next 2. What do they have in common? Well, they both have a 5 in common, so I say minus 5. Since I pulled out a minus 5, that changes that negative 15n to being a positive, so positive 3n. Pulled out a minus 5, so that changes that to being a plus 5. Well, I noticed that I got the same parentheses twice, so I carried on my GCF of 5 times 3n plus 5 times 7n squared. That's a 7n squared. 7n squared minus 5. Boom, there we go. That's it. That's all there is to it. Okay? Moving on to next problem. All right, next problem is factor. There's 4 terms. So that's factor by grouping because the greatest common factor here is 1. So I can dive straight into factoring by grouping. So these first 2 share an x squared. So I pull out an x squared. Okay? So then that becomes x plus 4. These both share a negative 9. So I say minus 9, and that becomes x plus 4. So now they both have x plus 4, so I can factor that out. And that's x squared minus 9. Well, x squared minus 9, guys, that's the difference of squares. That means I can factor that by tic-tac-toe. So x squared, negative 9x squared, 0. Okay, so that should be 0x out there. Negative 9x squared, I don't know where it went. I don't know why it didn't let me write. Anyway, so that should be 3x and negative 3x. That multiplies to negative 9x squared, but adds to 0x. X squared and 3x, what do they have in common? X. X squared and negative 3x, what do they have in common? X. X times what is 3x? X times what is negative 3x? Go across, go across. So we get x plus 4 times x minus 3 times x plus 3. And that's all she wrote. Okay, number 8. The total of two polynomials is that long polynomial. If one of the polynomials is that long polynomial, what is the other polynomial? Okay, so what this question is asking, guys, is that basically I added, that's what total means, two things together and I got this. Okay, so I added two things together and I got that. Okay, so I put two things together and I got this long polynomial. Actually, I need a little more space. And I got this long polynomial of 5x to the fourth plus 2x cubed plus x squared plus 5x plus 4. Okay, that says plus 4. We just can't see it anymore. Okay, so plus 4. All right. One of the things I added there is this 3x to the fourth plus 2x cubed minus x squared plus x minus 1. Okay? So what we're trying to do is we're trying to find out what is this other polynomial. So basically, guys, you can ask yourself the question, what would I have to add to 3x to the fourth to get 5x to the fourth? Well, that would be 2x to the fourth. What would I have to add to 2x cubed to get 2x cubed? Nothing. It's already 2x cubed, right? What would I have to add to negative x squared to get a positive x squared? In case you can't read that, the positive x squared is just coming from right there. Okay? Well, what would I have to add to negative x squared to get positive x squared? Well, hopefully you're like, well, I would need something to bump me up to 0 and then something to bump me up to 1. So that would be plus 2x squared. What would I need to add to x to, my goodness, I can't read my own handwriting. Yes, to x, all right, to get to 5x. Well, hopefully you're like, oh, I would need to add 4x. And what would I need to add to a negative 1 to get to 4? Well, hopefully you're not going to say 3 here because that would only get you to 2. Remember, you're trying to go from negative 1 to 4. So hopefully you're like, oh, that'd be a plus 5. And there we go. Okay, number 9. Multiply the polynomial shown. So we're just going to say a times a squared, so that's a cubed. A times negative 4a, so that's negative 4a squared. A times 2, so that's plus 2a. So I've done a to everything inside here. Okay, so now I can move on to this negative 1. Negative 1 times a squared is negative a squared. Negative 1 times negative 4a, negative times a negative, makes it a positive. 1 times 4a is just 4a. Negative 1 times 2 would be negative 2. So now I just put like terms together. A cubed minus 4a minus 4a squared minus a squared. It's going to be minus 5a squared plus 2a plus 4a, so that's plus 6a minus 2. And there we go. Okay? Moving on. Number 10 says simplify. And what's going on in between these two? I'm adding. So all I'm trying to do is add like terms. Negative 7x to the fifth plus 5x to the fifth. It's just negative 2x to the fifth. Okay? And then there are no other x's to the fourth. I like to go in descending order on powers. So then I'd say plus 10x to the fourth. Okay? Then next I look for x cubes. There are none. X squares. There are none. So the next thing I look for is just x's. So negative 2x plus 7x is plus 5x. And then I would do 14 is by itself, so just plus 14. And there we go. That's it. Last but not least, number 11. Okay, the hard part about number 11 is making sure you don't forget that this minus sign changes the sign of everything in here. So this is going to become minus 10a plus 2a to the fifth plus 14a to the fourth. So that means you're going to put like terms with like terms now. 12a to the fifth plus 2a to the fifth, 14a to the fifth. And then I look for fourths next, because remember, I like to go in descending order based on the power. So the next descending power would be the fourth. So that'd be plus 14a to the fourth. Then I look for cubes. This is the only cube right here. So minus 10a cubed. Then I look for squares, which there are none. So then I go to a, negative 6a, negative 10a. That makes minus 16a. And there we go. That's all she wrote because there's nothing else to this problem. All right, guys. Thank you for watching. Let me know if you guys have any questions. Send me an email. Send me a remind. Just make sure you get a hold of me in any way, shape, or form. Thanks, guys.